I'm here to introduce our next speaker. It's my great pleasure to introduce Harvey Ivey. Harvey is from Southern Company. He has 35 years in the power generation industry in positions ranging from plant operator to plant manager, most recently serving in an engineering leadership role to stand up a new organization to address automation and cybersecurity needs for both current and future generating assets for Southern Company. He joins us for his second year, presenting as a keynote speaker, and we'll be talking about improving situation awareness of plant operators through PowerGraphiX. On a personal note, it's been my pleasure to work with Harvey over the past 3 years. He's the kind of customer that we love, tough but fair, drives us towards new solutions, and at the end of the day, he's made PAS a better company, and we thank him for it. And with that, Harvey Ivey.
One of my responsibilities in Southern Company is to manage our cybersecurity program. We've had a lot of discussion about that today, but thank God I don't get to talk about that this morning. I get to talk about something that I think is kind of fun. It's something that I've enjoyed working on in Southern Company because, having been an operator early in my career, I've lived through the transition of the old pneumatic controls that I think we talked about earlier, through the implementation of digital controls. And in that process, I think we took a great tool, a great platform in the digital world, and we very eloquently misapplied it in a lot of ways. We took that great tool and we unlearned some things that worked well in the old analog era, and used this great technology in ways that it really didn't help us all that well. So I want to talk about a transition that we've made in Southern Company over the last few years to try to relook at the way we present information to the operator. And the whole intent here of our effort has been to plug that operator back into the process, make sure that he's aware of what's going on the unit he's controlling, and be part of the process. We had actually, I think, gotten to a point where the operator was operating by alarms. The systems had gotten so cumbersome and complicated that a lot of times they didn't see things coming until it was too late. So we've been working on this now for about 5 years. We've worked with PAS through most of that 5 years, and they have really, really been a great ally to us in our evolution to make things better for the operator. So, to start this presentation, I want to talk about the problem we were trying to solve. Okay, this is, Keith talked about, Keith, you still here? Keith, okay, Keith, you talked about earlier about trying to put better tools in the hand of the operator so the operator can do their own graphics development. Well, I'll offer you a word of caution there. Don't give them all the tools, and don't pull the engineers completely out of the process. Because I think in some cases in Southern, we had actually abdicated the development of graphics to the operator. And so we had given them the tools to do this, but we kind of walked away and said, go have a good time. When you're ready, we'll start the unit up. That really created a lot of problems for us. For example, this is one of those graphics that an operator created, spent a lot of time making a pretty boiler. It looks really good. I mean, it's nice and colorful, it's pretty to look at. But I've asked the operators on that particular unit, I've asked the plant manager and the ops manager, is this boiler operating properly? You call this your boiler overview, but help me, is this thing running the way it's supposed to run? I haven't gotten a good answer yet because there's really not enough information to answer that question. So that's what happens when you turn an operator loose without a little guidance. Now this is what happens if you turn an engineer loose without a lot of guidance. Lots of data. Data's good, right? Data's a good thing. We need lots of data. This is, unfortunately, one of our newer graphics before we started down the PowerGraphiX. We spent millions of dollars building scrubbers, and this was the graphic that's supposed to help us know if that scrubber's working right. Danged if I know. One of the things that really stands out to me is just the use of the colors here. The color red, last time I counted, meant 4 different things on the screen. So it really has no meaning. So as we started down the path to fix this, we knew we had a problem. There's something wrong with the picture. We knew there had to be better ways to do this. We were very inconsistent. We had a few standards in place, but they were mostly personal preference. We used a lot of color. We used it abundantly. It's really good when you're wanting to sell a DCS to a customer with a lot of splashy colors and graphics, but to an operator, it's not that helpful. We saw that the way we were doing things in the past, we basically built a custom set of graphics for every control project we did. And that custom solution was costing us a lot of money, a lot of time, and create a lot of problems for the operator. So in the end, we decided that the graphics themselves need to be handled with as much care as the rest of the control project. It needed to be more of an engineered solution. So we needed the operators involved, but we couldn't just hand it off to them. Analogy I'd like to make is I got to fly home from here later, and I hope that pilot didn't build the control system that's flying that plane. He's probably really good controlling it, but he's probably not the guy that you want doing that by themselves. You want their input. And that's the process that we took, was to have a lot of engineering and a lot of operations knowledge combined. And I'll talk about how we got there. Well, when we started looking around, we realized we had the problem, we needed solutions. We did a survey through the industry of different sources, and we landed on this book, the HP HMI Handbook, that was written and sold by PAS. And that has been an extremely valuable asset in our evolution in this area. So we read the book, we learned a lot of good principles, learned a lot of good concepts. We combined the things that we'd already discovered ourselves and launched down the road to solve the problem. So if you go back in history about 30 years, this is a 720 megawatt coal-fired drum unit, not far from Birmingham. At that time, it was the latest and greatest and newest. You see all the analog controls in the control room. There's a lot of good knowledge that went into building that control system. A lot of good, intelligent design that went into building that control system. And somehow in the course of going from analog to digital, with our excitement over the new technology, we abandoned, I think, a lot of the things that worked well in this environment. So we had the big picture. The advantage, the beauty of that control room was my friend Matt there, standing in a control room, could see everything going on with that unit. He had the big picture. He could see everything from the coal coming in to the megawatts going out from pretty much anywhere in that control room. Well, with the adoption of the digital era, we took that big picture and we chopped it up into 17-inch screens. And guess what? When you build control systems and you ask operators how many screens do you need to operate it, the answer is more than the last one. So we noticed that every project, the number of monitors that the operators were asking for was ballooning. This particular picture is the exact same unit about 5 years ago. When we redid the controls 5 years ago, that's about 40 monitors. But if you pay attention to all those little monitors, you'll notice that some of them are duplicated, some of them 2 or 3 times. And what we've learned through working with PAS is, because of the work the ASM Consortium did, Abnormal Situation Management Consortium, you can read about it in the book, What they learned in their studies is an operator can really only handle about 4 screens worth of information in an abnormal situation. So this wasn't working. My other friend there, Mr. Couch, probably went home with a neck ache and a headache on a fairly regular basis operating in this environment. So we wanted the big picture back. So we started this process that we call PowerGraphiX, and I'll talk about how we got here. This is kind of a major part, of the end product, which is the level 1 overview screen. This gives the operator that big picture. And I'll talk about how we developed this. It took a lot of operator input. There's a lot of good sound engineering, a lot of good use of the concepts of high performance HMI graphics. But it's what we believe is a very good blend of good solid engineering and really good operator input. I'll talk some more about this. So with that, now that we have the big picture back, we can do this. This is the same control room. I've shown all 3 pictures. It's evolution from the old analog world to that cocoon of monitors to this is as of 2 weeks ago. We started this unit up about a month ago with the new PowerGraphiX format. I'll show you the actual picture. This is a rendering of what it was supposed to look like, and I'll show you in a few minutes a slide of what it actually does look like. A whole lot like this, but it actually has the screens with data. So we got the big picture back. Something else that we learned that we hadn't done very well is we had not helped the operator navigate very well. If you notice those first 2 graphics that I showed you had buttons ringing the graphic, we thought we were helping the operator, so we tried to think through where could he possibly need to go from this screen next. And so we put buttons that took him there. The problem with that sounds good, but every graphic has a different set of buttons in different places when you do that. We didn't realize that necessarily at the time. So you have to develop the hierarchy and the structure and get that right so that your navigation works properly. So we have the 4 levels of hierarchy that are described in the book. The level 1 is the big overview, stays in front of the operator at all times. It doesn't change. He doesn't change that screen. He doesn't control from that screen. It's a monitor only. That's the big picture. That's what it's for. How is your unit healthy? All the way from fuel and air and water, every system on your unit, is it healthy? The level 2 is where he actually does his work. And I'll talk about in a few minutes. When we started this project, the first unit we tackled had 300 graphics. Well, can you imagine as an operator trying to figure out which graphic I need to go to solve my problem? The last one, the one that I showed with the 3 control rooms, it had 600 graphics. And that was because we weren't really managing the amount of information. We didn't have the hierarchy right to start with. By doing this and getting this right, where you have a level 1, which is everything, you come down to a system level like fuel, and then you come down to an equipment level like a pulverizer, and then there's diagnostics below that. If you do that consistently across all your systems, then you wind up with 70 graphics to do what we were doing with 300 graphics. And you have a very structured navigation like this. Each one of those branches off that tree is a graphic. That's all the graphics for the whole unit. Instead of 300 or 600, it takes 70 graphics to do the same amount of work. And this navigation process is 2 clicks to anywhere. So when an operator gets this main menu, he can click on either those level 2 graphics, the level 1 at the top, or any of the level 3 or 4 below, and immediately go there. And then you'll see in the bottom left, these 3 buttons show up every time in the same place on every screen. So he always knows how to get back here. It's always 2 clicks from anywhere to anywhere else. And it's the same 2 clicks. So it's much more intuitive to the operator. And that shows the location of those buttons on every screen. All right, this is a fun part of the presentation. I love this part of the presentation. Is this cat healthy? All right. Would you consider yourself technical? Is this a technical crowd? I think probably technical. All right, technical folks like data, so we took the cat to the vet. We got some blood work done. Here's your results. All right, now answer my question. Is the cat healthy? What's your problem now? You're smart folks. What's wrong? Well, just think about it. We do this to the poor operator every day when we give him screens full of digital numbers that don't have any context to tell him, is that a good number or not? All right, well, what if I took that information and I told you what normal looked like? All right, that's the normal range. So then you could ask yourself, is that number in the normal range? And you could work your way down the list for each one of those data points that you'd been given with the context of what normal looks like. And in the end, looks like the cat looks healthy. Everything checked out. Well, what if instead of all those numbers, I'd given it to you like that? Could you have answered my question a little quicker? I would say that all you really needed to know to answer my question was this. The numbers really didn't necessarily help you a whole lot. This concept is built into PowerGraphiX at every level, but particularly the monitoring, because when an operator is monitoring the plant, he doesn't really need to know at every instant in time that the number 4 bearing is at 3.7 mils. At some point, he's going to really need to know that. But when he's just monitoring to know if that turbine is healthy, he just needs to know, is it in the good range? And he can process a lot more information if we present it like this. So as we went through the process, one of the things that, concepts spelled out in the book is standardizing objects. Initially, we created one object for everything. It was just a straight bar, and it had these lines, and built our graphics, put it in front of a bunch of operators, and they looked at it and said, man, that looks like a bunch of cornrows. I can't tell anything from anything. So we had to back up and regroup, hurt our feelings as engineers. We thought we'd got this right. But the operators helped us create objects that make sense to them as an operator. If you look at some of those and your knowledge of controls, those are fairly intuitive. I'm going to talk about a couple of these in more detail. All right, this is basically how a standard object works. If you see the blue dot, that's where I am right now. The white is the good range, the normal range. The gray are the alarm bands. If I move into gray, I get an alarm, either low or high. And the black says that some control action is about to happen if I don't fix it. Either I'm going to run something back or I'm going to trip something. I'm going to take it away from the operator and do something to protect the asset. So a normal operation, this is kind of what an operator would see. Say that blue dot going up, he gets an alarm, and you see the little spark trend on the left. All those are elements that are built into the process. But it's pretty obvious when things went bad, when he got an alarm situation. This was a pretty cool tool that our operators helped us build, because traditionally when we show turbine vibrations or bearing vibrations on some device like a turbine that has multiple bearings, we would draw the little diagram for a turbine and we'd sprinkle all these numbers at every bearing, and it takes up a lot of real estate, and it's not very intuitive whether that thing's working well or not. So we asked our operators to help us think through, how can I show you all that information in a better way? And they said, well, you taught us about pattern recognition as part of our training to do this workshop, so we think we ought to use that. And so we worked with them and they came up with this, and I think it's a pretty cool tool because you can show a lot of information in a small area. But in this case, we're showing turbine vibration on multiple bearings in a very small area. And if you notice, realizing that humans are really good at pattern recognition, as an operator, I'm going to very quickly get used to a bunch of little bars stacked together, and then there's 3 that are a little separated. I don't have to know which bearings those are if all I'm interested in is my turbine okay? But if an operator watches that over some period of time, he might see this happening. This can happen in seconds or days or weeks, but he'll notice my pattern's not the same. So therefore, the way PowerGraphiX works, he would click on this bar and it would automatically take him to a graphic that helps him solve that problem. And on that graphic would be the numbers that he needs. You know, it's bearing number 7 is at 5.6 mils, which is more than the alarm setting. But it's a great way to put a lot of information in a small area. And we used pattern recognition everywhere we could because it is such a potent tool that we humans possess. For example, if you noticed in that original control room, there were a lot of old analog draft gauges. I was an operator early in my career, and those things were pretty good, a pretty good tool for an operator because they were all scaled and ranged such that if the little dial was in the middle of all my gauges, I was okay. Well, somehow we went to digital, we threw that away and just gave me a number. Well, we went back to if the needles are all in the middle, I'm okay. Because I can look now at several parameters and almost instantaneously I know everything in my draft gauge is good. One thing that the operators helped us do, and I'll talk about our workshop here shortly, is they helped us think like an operator. How's an operator think about a power plant? Well, he thinks about his fuel system, his air system, his feed water system, his generator, his turbine. They think in systems. And so we designed our graphic the way they think. And we arranged the information the way they think. Another thing that we tried to do is everywhere possible to group like parameters using these analog indicators so that you could detect an anomaly. If I've got 6 pulverizers and one of them misbehaving, if I put all 6 of them together like this, that one that's misbehaving jumps out. You know, it looks different. So as an operator, I need to go investigate. And this is something that it's probably my favorite part of what we did. As a controls engineer, we revealed to the operator some information that traditionally he had not had access to. Traditionally, we just gave them process variables. That's what we expected them to look at was process variables. What this center circle reveals to the operator is the output of his primary control loops, like his fuel controller, his air controller, his feed water controller. And again, some engineering was done here and some scaling so that if a fuel controller is not satisfied, if it's taking corrective action to get more fuel or decrease fuel, he's going to get a bigger bar. So he tends to see things happen there before he notices an individual pulverizer that might be getting in trouble. A lot of that has to do with the way you scale the error. But our operators love this because when they look up at this level 1, they look at that place first. If they don't see any blue bars there, then they take their time scanning the rest of it. But if they see a blue bar anywhere there, they know where to go pay attention. Is it a fuel problem, an air problem, etc.? And those are the multi-point indicators for the turbine and generator that we talked about. Trending was a really, really cool tool that we used to have with circular charts and strip charts. We used it a lot. But for some reason, with the digital era, we were given, I think, better trending tools than we had in the past. We just didn't use them as effectively. As an operator, I love strip charts because if I knew where I had been, I knew where I was likely going. And so I could watch that trend on the strip chart and I could see when trouble was beginning to happen. So we've tried to use the trending capability that's so powerful in the digital controls today in more intelligent ways than we had previously. We used the spark trends wherever the operators felt like they added value. And then the black box in the middle are what we call engineered trends. We picked some key parameters and we scale them in some cases where things overlay each other. If everything's scaled properly, everything's running, you only see one line. But if something gets out of balance, one of the lines starts to separate, like fuel flow versus air flow versus steam flow. Then you know to go look somewhere else. So I think one of the keys to helping us get this right was the fact that we pulled together 8 of our best operators and operator trainers, sequestered them for 2 weeks in our controls lab where we build all of our control systems. We taught them for 2 days all the principles that we've been talking about. We asked them to help us get this right. And they did a phenomenal job. It was amazing when you ask an operator to come out of his cozy control room and go to corporate to do anything, what's an immediate reaction? What am I here for? What are you doing to me? My plant manager said, come here. I don't know what I'm supposed to be doing, but I'm here. Well, it took us about 2 days to break through because you have to help operators understand what's in it for them. But when they really understood the concepts of what we were trying to do, it was incredible, the end product versus where we started after we got their input. By the end of the first week, I was at a whiteboard drawing something for one of the graphics, and I knew we were on the right course when one of the most resistant operators says, hey, what you just wrote doesn't fit the PowerGraphiX stuff you've been teaching us. That's not right. I knew at that point, hey, we're on a good course. But those operators really helped us think like an operator. So we had a combination of controls engineers and operators working together. Part of that 2 weeks was we developed this level 1 overview that we've talked about, and then we went down to the level 2, and we developed the graphic for each system. And the critical part of getting that right was to have the operators help us identify all the tasks that they do with that system. And then for each task, for example, starting a pulverizer, shutting down a pulverizer, putting gas igniters in or putting oil igniters in, hitting the master fuel trip, all the things they might need to do with their fuel system, and then asking them for each one of those tasks, what information is important to you to get that task right, to do that task. And that was a huge benefit going through that process. And our goal was at the end of the day, rather than flipping through 20 screens to do a particular function during startup, which we had seen before this process, we wanted to reduce that significantly. We had a goal of having the operators do 80% of their operations from those 6 level 2 screens. In the end, it was over 90%, and the operators loved it because they didn't have to navigate and flip screens to do their job. What they needed was right there in front of them. So some of the benefits we've seen: consistency. I actually, in my lab, had an ABB system and an Emerson system in the same room running simulator software back to back, and you could not tell the difference. The graphics are identical. The way they work is identical. I could take an operator off this Emerson unit, spin his chair around, and he can operate the ABB in it. We've actually had some transfers since we started this process. They need about a day of training to know that I've got 5 mils instead of 6 mils, and they're good to go. So there's a lot more science and less art. We don't spend time, drawing pretty boilers and things like that. We try to give the operator what they need. A key to it that's described in the book is developing a philosophy document that describes what you want to accomplish, a style guide, and an object library per every platform so that your ABB system works just like your Emerson, like your Alstom, like whatever. Okay, but the best proof to me is this is what operators have told me as I go around and visit the sites that we've done this at. When we started down this path, we really didn't plan on saving money. We were planning on helping the operator. But there's some intuitive or maybe not so intuitive benefits from being consistent. One thing, we've had a lot of discussion about cybersecurity, but if you imagine those 40 monitors in that control room, you can typically drive 4 monitors out of a box with all the hardware, the software licensing, cybersecurity costs associated with that box. So if you go from 40 monitors down to 6, you've just cut, in our case, $100,000 off that unit just in licensing and cybersecurity cost. So we've seen unintended benefits from a cost just by the driving consistency. We've done a lot of this so far. These are all the projects that we've completed that we have either stood up. We've got a couple of greenfield opportunities, but most of these are conversions that we've done to date. This year, we've got some really big units, a couple of 500 megawatts, some 700 megawatts, some pretty big units. We got about 3,000 megawatts that will be converted this year. We've got about 4,000 megawatts that will convert next year. Now, I didn't go beyond 15, but our plan is to convert. We have about 40,000 megawatts of generation in Southern. We're not going to convert it all because some of them are very old and very small units, so we're probably not going to fool with those. But we'll probably convert about 30,000 megawatts to PowerGraphiX in the next 5 years. So this is the actual control room at Miller. That's the one we started with that had all the monitors. That's what it looked like 2 weeks ago. The unit was at full load, and the operators absolutely love it. This is a 2-unit in 1 control room design. This one started up, the first of the 2 units started up about a month ago. The other unit starts up in a couple of weeks. And this is a phased approach. You know, it's not the whole, you notice we still got some bench boards in the back. Over time, all that will migrate to the DCS. And we also had an opportunity. We had some interest from one of our peers, and they came down a couple of years ago and met with us, and we talked through this, and we developed an arrangement to license all of this to Dominion Power, and they have it on 1 unit and about to start work on another unit, combined cycle, that will utilize PowerGraphiX. And we were recently notified that we won the SEE Production Project of the Year award, so we were pretty excited about that. So I mentioned we've had a lot of external interest, not just Dominion, but a lot of folks. So I'm focused on Southern Company. I got more work. As you saw that list of plants I've got to convert, I've got more work than I can do. Right now I'm kind of holding off some plant managers that want it done yesterday. But we felt like we've invested a lot in this product. I think one of the advantages working with Eddie and the team here, one of the advantages we had was we had operators. We had operators that could interact with us and help us get this right. So we felt like this was a really strong product. We felt like it could become an industry standard. So we wanted to partner with somebody to see if there was some interest in the market. And pretty quickly realized there was. And we wanted somebody who wasn't necessarily married to any particular control platform, because in our world, we're already doing this on Emerson, ABB, Foxborough. We're moving to turbine controls next. We're going to have it on a couple of platforms there. So we wanted it to be control system agnostic. So the combination of that factor and the factor that, hey, these folks wrote the book. I mean, they really started this whole evolution. Then we immediately, wanted to talk with Eddie and the PAS folks about, let's look at what we can do with this beyond Southern Company. And it's been a really good experience. It's been very, very interesting to see the evolution of what an operator can do today with good information compared to where we started when he didn't have. So with that, do we have time for a couple of questions? Yes, I see some hands back here. Yes. I cut out some slides because I've only got a minute left as it is, so I cut out some slides. But yes, there is a hierarchy of alarming. That was a priority 1 alarm. They're priority 2s and 3s. They have different colors, a different shape, and a different number. So there's triple coding on the alarming, but you would get the same box around the process variable that was in alarm, but it would get a different color and a different code and a different number, or different shape and a different number. So yes, we do have that built in. All right, seemed like I saw another hand. Okay. Yes. Level 1 is the system. It's everything that an operator is interested in that power plant. It's fuel system, air system, water system. Below that, the level 2 is you break down a system and go in more detail. That's where you actually operate that system. Say the fuel system would have all the pulverizers, so it could adjust its feed rates on coal. It would have his oil igniters, his gas igniters, anything related to fuel. So the level 1 is the whole plant, all systems, the whole unit. I'm sorry, I'm confusing your question. The whole unit. Then the level 2 is a system within that unit.
Okay, so my question actually is how do you avoid overly duplicating information between level 1 to, because I assume all the important information in level 2 will be in level 1. Level 3 and level 2.
No, it's not. It's
not right.
What's in level 1 is a small subset of what's in level 2, because you don't, to know if a pulverizer is healthy, you may only put 5 or 6 parameters on the level 1, but when you get down to the level 2, you'll probably have twice that many, because you're interested in startup and shut down more parameters at level 2 than you would be in your level 1. And that's, again, part of the iteration with the operators, asking them, help us. We really worked hard to pare down what was on the level 1, because we knew it was going to be a lot of information. We didn't want it to be too much. And so they pared down on level 1 just the things you need to monitor to make sure it's healthy, not all the things you need to monitor to control every possible perturbation of how that thing operates. There's a lot more information on 2, and then you go down to level 3, which is the diagnostics, and you might have a permissive screen that shows, I can't start this pulverizer because this particular damper is not closed. So there's a lot more information available even below the level 2 that you would not reflect on 2 or 1.
Harvey, over here in the corner.
Yes, sir.
It's good and hard to tell which systems these things are overlaid on. How many different DCS manufacturers and models have you done this to?
Currently, we've done the Foxborough, the Emerson, the ABB. We've done a little work with Siemens, and we're doing some more work with them. And there's another one we're about to work with that I can't share yet because I don't think we have permission yet, but we're working with another vendor to add their turbine controls. And then there's other folks you'll hear about here in a few minutes that don't want to steal all the thunder, but you'll hear about some others here in just a few minutes.
Great, thank you.
Thank you. Yes?
Have you done any benchmarks on how effective this has made your operation or increase your production?
Well, that's a very interesting question. Eddie and I have had this conversation very recently. We really have not done any formal benchmarking. To this point, the anecdotal response and performance from the operators has been far more than enough to convince other plants to go down this path. I don't have the authority to make any plant do anything. I just provide what they ask for. And you saw those plants on that list. Actually, we're having to stall plants because they want to make this conversion, because their operators have talked to the other operators who are operating the PowerGraphiX units. And they're the salespeople for this. I quit trying to sell this about 2 years ago when I got more work than I could do. So we haven't really formally done that, but I've been talking with Eddie because I think we do have the integrity product now on some of the same units we have PowerGraphiX. And we want to use the integrity product because I have a few units that I had integrity before I did the conversion. So I should be able to go back and look at how many times an operator changed graphics, how many operator moves did it take to do a certain function. So we're going to work together over the next year or two once I get some more runtime on these most recent units that have made the conversion. And I believe we'll have a pretty powerful tool that will demonstrate the actual benefit. Okay.